Hello and welcome all for today's session. If we look from the topics that we had to cover uh, today, we will look into Lambda, a bit of serverless architecture. We have already looked into EC2. Elastic Beanstalk is more of a managed service. So in case if you have your code and you do not want to manage the underlying provisioning, deployment, patching, and all, Elastic Beanstalk is the right tool for that. It supports a lot of languages like Java, .NET, Ruby, Python. It's able to handle a lot of languages. It also supports Docker. So in case if you have your code and you can containerize into a Docker, you can use Elastic Beanstalk for Docker deployments also. From the storage perspective, S3 we have looked into. Today we will look into a bit of EBS, EFS, Storage Gateway, and Snowball. So let's start with EBS, EFS. So EBS is Elastic Block Storage. Let's go and do a bit of block storage. I think that's So we will try first understand what is EBS and what is EFS, and then what we'll look mainly is EBS versus EFS versus S3. So that if there is a scenario-based question of like when to choose which storage option, you have the absolute clarity. So S3 is, as you know, is more of a object level storage, and to access it, it is done over web via APIs, REST APIs. It can also be done securely, depending upon how you architect your network. You can have a private VPC endpoint through which you will be able to access it without going into the internet. But overall, all the objects, whether it is writing it to or reading it to it, are accessible via API. For Elastic Block Storage, it is more of a think about a storage which is attached to EC2, which is the Elastic Cloud Compute. So if you want a block storage which is attached to EC2 for high performance, then Elastic Block Storage is the right storage option. So for the broad range of workloads, like whether it is for example database, your database consists of multiple things like both compute and storage. So compute would be like any SQL queries that it needs to run, or any caching it needs to be doing. It does there, but it also requires a lot of storage. So the storage is on a EBS, so that your compute is able to access the storage in a very, very low latency fashion at a high performance. So that's one of the use case. Enterprise applications, containerized applications. These are the few of the use cases of EBS. You can have a quick look about how it is structured here in this video. But what we'll be mainly going through is probably the features overview. Or even before that, we can go through a volume types, I believe. Yes, volume types. There are multiple volumes types based on your use case to use case. There are multiple volumes types. The volume types are either SSD based volumes or HDD based volumes. So like SSD, like solid state disk, and like a hard disk drive. Depending upon how your workload is and how fast you need to access the data, you will be using them. SSD based volumes are obviously faster and hence a bit costlier, and HDD based volumes are a little bit slower and hence they're a bit cheaper. They come in multiple flavors. GP2, which is a general purpose. It is used mainly for all the general purpose use cases. IO1 and IO2 are mainly IOPS provisioned. That is input output per second provisioned, which is like for a higher performance. So for any of your production workloads, any of your database production workloads, something like that, where the IO is very intensive, that's when you will be using IO1 or IO2. IO2 is just a next generation for the next generation EC2 instances. Or otherwise, for the cheaper options, we do have hard disk drive based volumes, which is ST1 and SC1. This is like cold storage and hard disk drive based, but we'll be able to look at them in more detail here with a comparison of these in the features overview. If you took EBS volume types, then you will be having this solid state drives, which is SSD based, which are like three of them: EBS general purpose, GP2 or IO1, IO2, and hard disk drive based. We have cold and throughput optimized. Yeah, as you can imagine, like this is like the slowest and the cheapest, and these will be like with the highest, the price from comparison, but also from the performance perspective. So this table, in case if you can have a mental picture of this table, this will really help you in understanding what level of throughputs each of these can support. So if you see from the IOPS perspective, that is a maximum IOPS volume that any of these drives can reach. So if in a cold hard drive, it is like maximum is 250. If you want an application in which the IOPS is between like around 500, then you will go for throughput optimized HDD, and there might be a scenario based questions like these. But in case if you want like higher throughputs, then you would be needing to use SSD drives, and that's where for a general purpose you'll be able to reach up to 16,000 IOPS. But in case if you want even more than that, which is like mainly for the production workloads, real-time transactions that are required there, which are latency sensitive transactions, that's when you'll be using IO1 or IO2, which can go up to 64,000 IOPS. And then there is a max throughput, that how much throughput we'll be able to achieve, and those are like the numbers here. So go through this table. Having a mental picture of this table will really help in understanding the use cases for these. And as I said, from the pricing perspective, this would be the cheapest. Like you can see, like it's like 0.025 like dollars per GB per month. It is 0.045. It increases to 0.1, and then 0.125, and the provision IOPS is like 0.065, and so on and so forth. From other you can go through like the more details in case if you want to understand which all use cases it is used, and like a bit more depth. So there is a lot of information here in this specific feature page. But then it comes about the EBS snapshots. And when it comes to EBS snapshots, it's more like think about you have a laptop, and your laptop have a specific drive, and for this particular drive you're taking a snapshot so that in case if your laptop crashes, you'll be able to retrieve all the data. So EBS snapshot is something like that. The good part here is EBS snapshot is incremental. There's a concept called data lifecycle manager, through which you should be able to manage the snapshots of EBS, or you can configure them manually through the UI. Then at what frequency you need the snapshots, or you can do it manually. But doing it incrementally, it means that only the blocks that have changed after the last snapshots are saved. So if you're built only for the changed blocks, so you might be having 100 GB of data, but only 5 GB has changed. When you take the first snapshot, obviously it will take the full 100 GB snapshot, but from the subsequent snapshots, only the amount of data that is added, updated, or changed, is saved as incremental. So, and all these EBS snapshots are saved on S3. So let's say in a day you're taking 10 snapshots, you will not be paying for, let's say, 100 GB into 10 price. It will be only 100 GB plus the incremental of each of the snapshot. So that's the benefit, that you will be billed only for the additional 5 GB storage space. And then in case if you delete a snapshot, it is going to delete only the relevant portion of the snapshots, so that no other snapshots which are still there are not can be recreated. So it's like a series of a data that is saved for each of the snapshots. And if you want to go back in time and delete some of the snapshots, it is fine. It's going to delete only that particular portion of that particular data which is required to recreate that particular snapshot, which is needs to be deleted. Otherwise, all other snapshots can be recreated. That's on the EBS snapshots part. Okay, then there's another concept called EBS optimized instances. For an additional like low hourly fee, we can launch EC2 instances with the EBS optimized instances, which is like optimized for its networking, dedicated throughput between EC2 and Amazon EBS with the options of, these figures are not important, but in case if there is a question about that you want to have an increased throughput, what we should be doing. And in case if one of the option is that have a optimized EBS optimized instances, go for that. And then let us have a look what is so in general, one EBS instance is attached to one EC2 instance. That when you launch a EC2 instance, you need to attach a EBS to it, so that the each compute instance would be obviously needing a storage space where it can store its like temporary data or any other data that it requires to access it very, very fast. But then recently there is a concept of EBS multi-attach. So can attach EBS only the provisioned IOPS volumes, not the GP2 or any other, only the provisioned IOPS volume, to concurrently attach up to 16 Nitro-based EC2 instances. So as you know, EC2 instance has multiple families. There are a lot of families. Nitro-based EC2 instances are one of the newest family that we have. I'm not sure if there will be any question on these, but now it is possible to attach EBS volume to more than one EC2 instance. And that's maximum 16 EC2 instances, and they should be within the same availability zone. So that's one point to know. Otherwise, whenever there's a question on a, like there are multiple EC2 instances which needs to access data from one common, like a data store, then it is either EFS, which is Elastic File System, or S3. We will talk about Elastic File System in more detail so that you understand the difference between them. But yeah, that's pretty much on EBS. This particular page should help you understand all the features, and that should cover most of things. There is a concept of a burstable instances where you will be able to get a increased throughput provision. Let me try and get that. Give me just 1 second. What I'll do is I'll go into AWS console and I'll show you that. I'm trying to get logged into AWS console, so give me just a minute. I'll do that and I'll bring that up on the screen. In the meantime, if you have any question, please feel free to ask. Okay, so in AWS Manage Console, I'm going to EC2, and in the EC2, we'll be able to find EBS, Elastic Block Storage, and that's where we have a volume. So I can go to the volumes. I'll launch a EBS volume just to show all the different, options that we get. So we can create a volume. So if you see here in the volume, we do have these options. So magnetic is the old version, and otherwise we do have, and it is again, these two are based on HDD, and then we have GP2, IO1, and IO2. So let's say if I go to GP2, so if you see here, it says the SAS, this is the minimum one, this is the maximum one, and then it says the maximum IOPS that I will be able to get. So it says baseline of 3 IOPS per GB. So for every GB that I take, it will give me 3 IOPS for that. So if I go for 100 GB, it's going to give me maximum like 300 GB, and maximum I can go up to 3000, and it can burst stable up to 3000 GBs. That's per second. What I'll be able to get is that if I'm 100 GB, I am getting 300 GB per second. But then I will be able to, utilize the burst table up to go up till 3000 IOPS, and that's the maximum I can go for. But in case if I want more, I should be increasing the number of GB I'll get. So if I go to 150, it go to 450, but the max I'll be able to reach is 3000 per second. So yeah, play with these. Here you'll be able to find all those options. Plus, yeah, feel free to be aware of what is within the free tier and is not within the free tier, where you'll be doing these hands-on or playing around. And then if you see here, there is an option for multi-attach. So this was recently for 16 Nitro based isn't attached. Okay, with that, let us move on EFS. So if we read from the definition perspective, EFS is a simple, scalable, fully managed, elastic NFS file system. So if anyone would have worked on, at the storage file systems, NFS is an industry level protocol. So you can, it's a fully managed NFS file system to use within AWS Cloud Services and on-prem resources. So this is not that only EC2 instances will be able to access it. You can use it across on-prem and AWS. It is built to scale on demand to petabytes without disturbing applications. So you can, it's elastic. That's where the name elastic comes into picture. So it will be able to grow and shrink automatically when you add and remove files. It does come in 2 storage classes, like S3. If you remember, it comes in multiple storage classes. Elastic file system also comes in 2 storage classes. That is standard storage class, which will be by default used. But then we also have infrequent access storage class. So yeah, in case if you have data which is not being accessed very frequently, you can always push them to infrequent access storage classes. Do go through these to understand the specific use cases that when we should be using EFS. But what I would like to focus here is go on to features. EFS is fine. Infrequently accessed is fine, which is fine. Yeah, you can always have the, there's a something called EFS lifecycle management. You can always use EFS lifecycle management to put the data which is not hot, means which is not being accessed, into EFS infrequent access, and that is going to save you, on your cost. So it stores data at a lower cost, the infrequent access. But in case if you go to frequently asked questions, if I'm not wrong, it should be the 3rd question. Yes, which is when should I use EFS versus S3 versus EBS? And if you understand this particular difference between that, what to use when, it actually clarifies, because there are a lot of storage options. So this actually clarifies a lot. So EFS is a file storage service, EBS is a block storage service, and S3 is an object storage service. So in case if any of your question has these keywords, then right away you understand that which storage service I need to use: file versus block versus object. But yeah, this might have been in a cloud practitioner, but your solution architect questions will not be probably that straightforward. It might ask you a bit more understanding than just these keywords. So in case if there is a talk of NFS, if it's there is a NFS protocol being used, then it is going to be EFS. So if it's provides a file system interface, file system semantics, and it's concurrently accessible and storage for up to thousands of Amazon EC2 instances. The key here is thousands of Amazon EC2 instances. So in case if you want a file level access with a lot of EC2 instances, then EFS is the one. EBS It is generally single instance, but recently there are up to 16 EC2 Nitro specific instances only. And when it comes to S3, if there is anything about this, accessing the data via API, then S3 is there. So even thousands of EC2 instances, even like more than 1,000, 10,000 EC2 instances will be able to access S3, but all of them will have to do it via API. It's not an NFS protocol. It's not a direct connection. So they have to do it, through the REST APIs, and it might be just like a CLI command, or like a more of a a new get package that you will be able to access it through a C# code, or through a Java code or something, depending upon how in which programming languages you are doing and what code you are running on EC2 instances. But behind the scenes, it's all API through which you'll be able to access. And then there is a link here, learn more. And that's actually going to take you to this page, which says that when to use what, how is EFS different from Amazon S3, how is EFS different from EBS. So yeah, go through these. I'm not going to go through each one of them, but go through this and this should be able to clarify your doubts. And they have given a nice diagram here. As I said, keywords, file, object, block. From the performance perspective, like pre-operation latency, EFS is low and consistent. Object S3 is like it's low, but it always has a CloudFront through which end users will be able to access it from their specific location. For the fastest, is the lowest is EBS. It's like directly attached to the compute instance. Again, throughput scale, because there are multiple, we can go to multiple GBs per second. It is multiple GBs per second, but this is kind of a single GB per second. So go through this. This actually tells the use cases also. So in case if they do not say anything about the file system characteristics at all, they might simply the question might be that this is the specific scenario. In this specific scenario, which file system would you like to access? And if anyone talks about a transactional database, let's say, then for database, EFS and Amazon S3 will not be the right choice. Any storage for a database, you need to have a Amazon EBS. So go through these, different use cases, so that in case if there's just a question on a use case, you'll be able to identify the right storage option. Okay, so that's pretty much that I had to cover on EBS and EFS. Then from the next topic perspective, I believe, if I'm not wrong, it is storage gateways. Yeah, we can look into storage gateway. So let's for storage gateway also, should we start from here? I can show you here which all storage gateways we have, and then we can probably go into user guide to look into it in more detail. So storage gateway, there should be 3 types of storage gateways. So okay, what exactly is storage gateway? Let's take a step back to understand what exactly is a storage gateway. So storage gateway is a service that is used in a hybrid solution scenario. When I say hybrid, it means some of your resources are on AWS cloud and some of your resources are on your on-prem. And you want a hybrid storage solution, so that you want to your data to be used in your on-prem, but you want it to be backed up into, let's say, AWS, or vice versa. You want that entire data to be present in AWS, but you want it to be locally available, the data which is like, let's say, warm or hot onto your on-prem. So for these kind of scenarios, storage gateway provides you a hybrid storage infrastructure. So these are the use cases. So do go through these use cases. Most of the good part that I like about AWS Management Console is that a lot of information is given in the console itself, and the get started guide is also from here. You can go to the get started guide, which will take you to the user guide directly. But yeah, before going that, let's click on get started here and see. When we start creating gateway, there are 3 types of gateways, as you see: the file gateway, volume gateway, and tape gateway. So what does a file gateway does? It store file gateways in S3 with a local cache for low latency for the most recently used data. So the entire data is going to be in S3, and it is mainly used for the files system, and it does have a kind of a local cache in which the files are stored so that on-prem services will be able to use it. Similarly, we have a volume, and volume is of two types: cached volume and storage stored volumes. So volumes gateway is mainly for the block storage. It's not for the file storage; it's for the block storage, and it is it's stored in S3 with a point-in-time backups on EBS snapshots. So in case if you have on-prem, then they will all be stored in S3, and backups would be taken as a EBS snapshots, and S3 it will store in the S3. Those snapshots will be stored in S3. Again, there are two types. When say cached volumes, the entire data would be in AWS, and you will be having just a cache on your on-prem so that they will be able to access it at a low latency, the recently used one. But when it comes to stored volume, the entire data is on-prem, and at a specific schedule, the data is backed up onto S3 as a ABS snapshot. Then we have a tape gateway, which is mainly, let's say, in your on-prem, you have archive in terms of the tape. Then you will be able to save them in S3 Glacier using your existing tape-based processes. And that's pretty much that you have to understand. You have to understand the use cases of these and understand in which scenario which of the kind of storage gateway would be fitting in. And for the best thing that for would be, to go to the user guide and understand that. Let's see, in case if there are. So as I explained, right, you should be able to understand this, what exactly is a file gateway. So one thing point here is the file gateway is a file system. So obviously it will be a NFS, or we include the SMB. So in case if there is a NFS file protocol, which is like industry file protocol, or SMB file protocol, again industry file protocol, that is file gateway. It does tell you which versions are available, though that will not be required. And then when it comes to volume gateway, again there are two types: cached volumes and stored volumes. Then the tape gateway is mainly for your for archives. In case if you have on-prem for very long, all the data that is archived are stored in a tape format. So how you can actually leverage AWS in that. For this specific, the provisions like I think even volume is is Internet Small Computer System Interface, which is not ISCSI. That's what is being used. I believe there were a few diagrams that is going to help you better. Yeah, so here it is. So in case of file gateway, as you see, you have an on-prem application server, which is being connected via SMB or NFS, and we have a storage gateway, and the data is actually transferred to S3, and it can have its own lifecycle management, that how much data we want to store in S3 in frequently accessed or Glacier, and that's your file gateway. And the connection between on-prem and AWS can be via internet. There will be a VPC, or they can direct connect in case if you have a dedicated line between them. Volume gateway, I'm sure there will be so there are like these diagrams which is going to help you visually understand. So again, as I said, it's ISCSI protocol through which it is there, and the gateway is here, and it is cached, so it's going to get cached here, or the entire volumes are going to be stored here as snapshots in S3. When it comes to stored, then instead of cache, it's going to have the entire data here, and those snapshots are going to be here. Then the tape gateways, it has like multiple data centers where it has the tape drives and everything that is there. And there's a specific set of process that you need to do so that you will be able to use those to archive them directly into the Amazon Glacier, and it is virtual tape backed by Amazon Glacier that we'll be able to save there. And that's pretty much. Okay, then let's see what will be the next topic. Storage gateways, fine. Snowball. Okay, so Snow family. AWS has an entire Snow family. Uh, so when it comes to Snow family, there are mainly three devices. And why exactly a Snow family is used? It is like they are portable devices. Let's say you have a lot of data here on-prem, and transferring that data via internet, like storage gateway will help you to transfer data via internet. But let's say if you have a data that is in huge like petabytes, then transferring over internet is going to take a lot of time. So how are you going to do? So see, traditionally what we used to do is that we used to save data in external hard drive and ship it to somewhere, and that particular person will put it there. So Snow family is like we will look into it in more detail to understand, but that's one of the ways, like a portable devices to collect and process data and then migrate to AWS. So it all started with like porting the data from a huge amount of data from on-prem to AWS. Then we realized that there is a use case of having that compute also. While porting the data, there should be some compute that's required. And the only use case here, which we realized later on and introduced more products in the Snow family, was that it's not only that there is a huge amount of data and we want to move it. There might be data where there might be places where data is not huge, which is like, let's say, a very less amount of data, but the connection is so patchy that you will not be able to transfer it. So even in those scenarios, we'll have to use these portable devices. So it comes in three flavors: AWS Snow Cone, AWS Snowball, AWS Snowmobile. Snow Cone is like the smallest. Snowball is somewhere in between. Snowmobile is, like you would actually laugh when I'll show you the picture in case you haven't seen it before. Now let me see where I'll be able to find them. Yeah, here it is. So we'll start with Snowmobile. This is really, I love this. It is actually a 45-foot long ruggedized shipping container. These are managed by Amazon, and when you have a company who is, let's say, like have a data in data center, and you have a data center lease coming to expiry, and you want to transfer all the data, you book this. Amazon sends this truck, which is a military grade kind of a truck, and you will be able to transfer your data from your on-prem data center to AWS. So it's ideal for multi-petabyte and exabyte scale digital media migrations and data center shutdowns. A Snowball arrives at the customer site and appears at the network attached data store for more secure high-speed data transfer. After data is transferred to Snowmobile, it is driven back to a specific AWS region where you would like your data to be transferred to, and then data is loaded onto S3. As I said, it's a tamper-resistant, waterproof, and temperature-controlled with multi-layers of logical and physical security, like encryption and alarm monitoring and 24/7 video surveillance, and even there is a escort security vehicle during the transit. So even this is even used for highly sensitive organizations. And then the second kind of is for Snowball, and it's also for data migration for edge computing. It does have a capability of computing here in case if there's some processing required. It will be possible to do it here. It does come into two flavors: compute optimized and storage optimized. So when it comes to I believe there would be a like a diagram. I'll show you that. But yeah, just a point to note here is that your compute optimized comes with, I think, yeah, it's the storage optimized should be coming with 80 terabytes, and the compute optimized should be coming with 42 terabytes. Yeah, but there's a better diagram which I'll be showing you in a moment, in which this is in a tabular format, which is more easy to visualize. And most recently, we have introduced the Snow Cone, which I believe has maximum of 8 TB, 8 terabytes storage, and it allows you to transfer data even continuously if required from areas which do not have like patchy network or something like that. And very frankly, that's pretty much that you need to understand. Let me go into FAQ to see if that diagram is somewhere available. Use Snowcone family. Okay, you'll be able to get like a data like this. But I think I've seen a more tabular format, a comparison between these. I'll check for another link. If not, I'll search for it offline and I'll send that. Yeah, it was there somewhere, but I'm not able to find it right now. But the point to note here would be when it comes to these Snowcone, I'll go back. Snow family. From the mental picture, remember these. Snowcone, 8 terabyte. Snowball, comes in two flavors, storage optimized and compute optimized. If it is storage optimized, it will be having 80 terabytes of space. If it is compute optimized, it will be having 42 terabytes. In storage, storage optimized, it will be having 40 vCPUs for edge computing. And in case of compute optimized, it will be having 52. It will be having a more compute and less storage in compute optimized. And Snowmobile is mainly for hundreds of petabytes of data. And for that, we actually send a kind of a truck to them so that the data can be pushed onto it and then it is shipped back. Okay, now let's see what we should be covering. There's a question: are all these physical data storage devices? Yes, they are physical data storage devices. The Snow family, these are actually shipped. So that's a good question. We can actually go here, and we can go to the Snow family here, and here in this Snow family, large scale data transport. That's what they say. When you start from here, if you create a job, and when you start from here, one of the step here is give shipping details. So these devices are actually shipped to your location, physically shipped to your location. Yeah, it all starts from starting a country and all. I'm sure this will not be in the free tier, so I'm not going to attempt it right now. So yeah. Okay, and any other questions before we move forward? If not, I think we'll probably move to we'll talk about bit of serverless. We'll talk about bit of Lambda, and we'll talk about more other services like SQS, SNS, and we'll see what all we'll be able to cover. I don't think we'll be able to cover all of them, but yeah, it should give you enough food for thought. Okay, so give me just 1 second. Lambda. So we'll start with AWS. So when it comes to Lambda, we'll create a Lambda function to understand, but let's go back here and understand what exactly is AWS Lambda. So AWS Lambda It's a serverless computing option. It actually runs, allows you to run code without thinking about the servers, or without, like even thinking about the provisioning the underlying hardware. So yeah, it lets you run code without provisioning or managing servers. You only pay for the compute time you consume. So any function that you need to do, I'll give you an example. Let's say you have an and this quite often this scenario comes even in the questions, if I'm not wrong, that let's say if you have an website which is more of a, like people are storing photos in your website. They're uploading photos, and you need to do a function of kind of, like take the photo, create a thumbnail, save the thumbnail in another S3 bucket, let's say, and show that thumbnail on the web page. And that's a specific function. So one way about this is that you can always have a application created, and you can deploy that application in a virtual machine on a EC2, and keep it always running, which keeps on continuously monitoring your S3 bucket to see if a new photo has been uploaded. And then as soon as a new photo is uploaded, it is, let's say, polling in, let's say, in every 5 seconds to see if it is uploaded. If it is uploaded, it is going to pick that up, and it's going to convert into a thumbnail. But that would require, like let's say in an entire day you have only 10 photos getting uploaded. Then how it is going to work for you is that you are going to run a server 24/7, just to, in anticipation that there might be a photo that is being uploaded, and which is a perfect way to do, and this is how it has been always done. But then that's where, uh, when we talk to our customers, we understood that there are cases in which customers want to run a piece of code on a specific trigger, when the use case gets triggered. And that's where the whole innovation of serverless computing came into picture, of AWS Lambda, in which we provided the code and we hook it with a trigger. And the trigger might be, let's say, object got uploaded into a S3, or even a REST API. When our API is getting called behind the scenes, we just call the Lambda, which goes to uh, perform the function, and then respond back to the API. And that's pretty much, and that's where the whole power of Lambda comes into picture. It allows you to run code in virtually like any type of application or a backend service. And we'll look that when we'll create a sample right now. And when we automatically trigger it with a trigger, it is able to execute, and you only pay for the execution time, and not for the entire 24/7 duration. So that's pretty much on the background, but let's go and create a Lambda and see what all functionalities it gives, what all configurations it provides, and so on and so forth. So let's say I create a function. You can create it from a scratch. You can use a blueprint. I will go for a blueprint. Just we'll search for the simple hello world to start from. There's a blueprint. There should be a blueprint for hello world now. Let me search that. There should be a blueprint for hello world. Yeah, okay. So start a AWS Lambda function. So if you want to start playing around with, you can start with AWS Lambda function for the blueprint. I can configure it. So as you see, Lambda functions supports a lot of runtime, so a lot of languages. It's Node.js, Python. There are other Java, C#. We'll look into those in more detail. But yeah, let's configure the hello world Lambda function. You need to provide a function name. That is okay. I'm going to give you a test hello world. We can always create a new role or use existing role. So in this, we can create a new role, which is fine. Here you see there is a Lambda function code that has been given, which you can obviously modify. It's a Node.js code, so anyone familiar with Node.js will be able to understand it easily. It does nothing much. It takes it as an event, and it's going to console.log is nothing but printing those or logging those values that are coming in the event. So it's going to value 1, value 2, value 3. It's going to print those, and it is returning the key of the value 1. That is fine. In case if you want to test it, you can always, this is just given probably for a test that you can, uncomment and see if it is throwing an error or something like that. But we're not going to do that right now. Okay, and I'm going to create the function. It's as simple as that, because we are using our blueprint. But this has a very good, any if you're one of the .NET developer or a Java developer, it has, we have a Visual Studio toolkit for .NET developers. We have VS Code toolkits through which you'll be able to create these Lambda functions or serverless applications from the development environment that you have. So this is, more of a, this will how it will look. If you see that there's a configuration part, then there's a permission part, then there's a monitoring part. We'll look into this, but let's look at the configuration part. So this is our Lambda function. We can add a trigger that when this Lambda function is going to get triggered, and then a destination that where the output of the destination will be going. Okay, so we will look into these, in a bit more detail later on. What we'll do is we'll understand first what a SQS is, like with simple queue service, and then we'll hook a simple queue service with a Lambda. From the destination perspective, let's say if a Lambda is doing something from the Lambda itself, you can write it to, let's say, a DynamoDB. A cool serverless application would be that your front end is a API, your API gateway, then you have a Lambda, and then you have backend as your DynamoDB, and this entire web API can be created as a serverless fashion. Then we have the function code. Environment variables, in case if there are some like in any programming language, any code, we do require environment variables to change the runtime behavior. So let's say if there's a dev or prod or something like that, or any other thing, you can create those environment variables here. We'll also probably briefly touch upon systems management parameter store, or the secret manager, where you can store secrets, if you can call that, or secure strings. And let's say you want to save database credentials. Let's say, for example, this particular function is going to write to a RDS SQL Server database. So it will be needing to have the connection string, which might be having the username password of the database. Then you cannot save that, like in a plain text. You'll have to save them, and hard coding them within the code is also not the right thing. So you have to save them in a secure fashion outside the code, and your code can be able to access that. So for that, we use systems manager parameter store. We'll look into that, or secrets manager. So those are kind of use cases for environment variables. We can tag them. So you see automatic tag has been created because we created from the blueprint. Now let's come to the basic settings, and I'll clear and edit it. Runtimes. So this is important. So if you see what all is supported, we have a .NET, we have Go, we have Java, then we have Node.js, Python, and Ruby. So these are the 6 main languages. Other supported is more of the older versions of this, that in .NET Core 3.1 is the latest which is supported, but it is the like the previous versions. Similarly, Java 11 is supported, but we have the previous versions which are there. So, and you can also create your own custom runtime if the need be. Okay, so that's runtime, which is important. Handler is more of the entry point. If you have been like a C++ programmer or something like that, you know that a main is the entry entry point for any program. Here it is index.handler, and this need not be the same name. You can use it any name, and you just need to specify that name here. So click on info, there will be a lot of information that will be coming here that we can root through. The next two things is really important, which is the memory and the timeout, right? So let's say instead of a serverless application, you create a normal application that you guys create generally, and when you deploy it onto some machine, you always think about how much the RAM should be machine would be having, how much CPU the machine should be having, like there should be how many cores it should be having. So in the serverless functions, we always specify the RAM, like at the memory, and the function is allocating the CPU proportional to the memory configured. You cannot specifically tell how many CPUs you want. Like in EC2, if you remember, we always had vCPUs that we used to choose. Like T2 Micro will be having specific number of vCPUs. If you want to go for X large, it will be having more number of vCPUs. Here, you will be able to only select the memory, and that has a limits. Minimum is 128 and the maximum is 3 gigs, like 308 MB. So this is the minimum memory that you'll be able to provide. Even you have function, let's say it's very lightweight like ours, which is doing nothing but just like printing it. uh, Even for that we need to have minimum 128 MB, and the maximum we can go up to is 3. Similarly, timeout. So Lambda is mainly for like as I said, it's a use case when there's a certain activity happening and you want to get the serverless function triggered. So it is mainly for use cases in which the execution time is fast, and that is why you would not like it to be running always. So it has a time limit of like timeout. So its maximum timeout is 15 minutes. So you cannot have a timeout of more than 15 minutes. So if you have a long running function which takes more than 15 minutes, then Lambda is not the right use case. You should ideally be thinking about containers. I would say go for containers, and in case if you still want to have serverless, then there is an option of serverless containers, which is AWS Fargate, way out of the scope right now. But yeah, that's where you would be thinking about in case if you have a long running Lambda functions, long running applications which cannot be done through a Lambda. Okay, I'm going to cancel this. I'll keep the base settings as same. And then we have monitoring tools. We'll discuss about that. VPC, in case if your Lambda function needs to be attached to a specific VPC, that's where you will configure it. Provision concurrency. So what happens in a Lambda is in case if there is no access to it, it is recycled. So whenever there is a first access happening, then it is getting loaded into memory. So the first of what we call as cold start, the first access to it might take some time, but it might not be always the case for the applications. They would like it to always keep it warm, so that in case if even if the first request, it should not be taking time. That's where the provision concurrency comes into a picture. You can always use provision concurrency to ensure that your Lambda functions are kept warm. So let's test this. We'll test this and then we'll monitor it. So what we'll do is that we can create a test out of this. So we can what we do. So to test it locally, so they have given this utility where you can give it a name. So this will be your, let's say, kind of the input JSON for this particular hello world. I'll create it. So it says value 1, value 2, value 3. When I click test, execution results exceeded logs. So here is the logs, and these logs is what are going to be pushed to Cloudwatch. We'll talk about Cloudwatch and CloudTrail also. So Cloudwatch is where all your application logs is pushed, and you will be able to create dashboards out of it, create metrics out of it, have insights onto it. So these are the logs which got created. This is the start request which happened, which is the end request which happened, and it gives a few more information. The request ID is this, and then, so if you see it kind of save this, and the return is value 1. So if you see here, it is value 1 equal to value 2 equal to value 3. That's what it is printing it here as a infos, and then it returned event.key1. Key1 was value 1, so it returned value 1. And if you want, you can always edit the code. So let's say in case if I edit this and I throw is more of a creating an error or an exception. So I've saved this. So now my data has been cleared. So if I test it now, it should throw an exception. So it has thrown an exception, and I believe it will be telling me exactly, it has caught an exception. The entry point is this, unknown application error occurred. So that's how all your so all this is happening in a serverless fashion, that whenever you're getting invoked, that's invoking or triggering it, that's when it is going to happen. But to look into that in more detail, what probably I will do is I will first talk about SQS, and then we'll come back here and we'll attach a probably a trigger to it. Okay, so any questions on Lambda? If not, I would like to move to SQS, which is Simple Queue Service. So again, okay, I do have, but let's see if, yeah, so Simple Queue Service. It's more of a any queue that you might have, worked with, MQ or Rabbit MQ, Apache MQ, IBM MQ, depending upon whichever you would have worked with. Uh, SQS is fully managed. It processes high throughput system to system messaging. Your queues to be decoupled. Like obviously, it is used mainly to decouple your architectures. In case of a microservices, so you can always one of your microservice can produce data and put into queue, and other microservices can be the consumers. So it is mainly used in those scenarios, especially in the serverless applications. This becomes very very handy. So there will be producers who will be producing the data and pushing into the queue, and your queue is going to be consumed by the consumers. A lot of benefits do go through these, but what we need to understand here is two types of queues. By default, a queue is a standard queue, and we can also configure it as a FIFO queue, which is first in, first out. Because it is distributed in nature always, so your standard queue will not kind of guarantee the message order or the number of times delivery. But in case if you want a guaranteed one, then you will have to configure it as a first in, first out delivery, like exactly one processing in the FIFO queue. We should be reading more about these. So what I'll do is I'll go here and I'll do this. It should be MSN SQS. Yeah. Not this. I'll go to the instead of going here, I'll go to user guide. So there are few terms that you should be understanding. So these are the benefits, which is fine. How it is different from Amazon MQ, SNS is fine. SNS we'll talk about it. It is more of a publisher subscriber pattern, mainly for fanning out. SQS is more of a storing the message so that other consumers can consume it. When we should be using what type of queue is here. Standard queue versus FIFO queue. That whenever there is exactly once processing and first in, first out delivery is required, you'll have to configure it as a FIFO queue. It is more like at least once delivery or best effort ordering. It's not that it's going to always mess up ordering with your messages that are coming. It's going to do the best effort ordering, as you see here in the diagram, the way it has been shown. Just one moment. So these are the two types of queues, and by default it is a standard queue, which we'll see when we'll create one. Okay, but there are a few terms that I would like you guys to understand. Yeah, here it is. So you'll be able to understand the basic architecture. In case if you want to understand how this distributed architecture works, go through this. It gives a very good explanation of when a component comes, then how it is distributed so that the message is not lost, and then how the visibility, timeout, and clocks and message delivery works. But the terms that you should be understanding is short and long polling. That's important. So these terms which are here in the bottom of the pages, which is like short and long polling, dead letter queues, visibility timeouts, delay queues. So these are something that you should be understanding in more detail. So when it comes to short polling, it likes if the configuration is short polling, then it's going to see that whether the data is there. If the data is not there, it is going to respond right away. When it comes to long polling, you can always specify a timeout. It is going to poll the queue that whether there is data. If the data is there, it's good. It's going to return. If data is not there, it is going to wait till the data has not been arrived, unless the timeout happens. Whether the data has arrived or the timeout happens, it's going to return. Otherwise, it's going to stay there. So the long polling is more like less number of round trips and the more waiting. Short polling is more number of round trips, less waiting. So to do understand these, like how it works on a short polling and a long polling. Similarly, dead letter queues, and in case you have been an application developer, you would understand that dead letter queues are mainly used for pushing data to a queue which was not processed successfully, so that they can be handled through a separate process, whether manually or some other automation. But in case there is any scenario about you know uh, there's a processing that is happening on the main queue, and there are few data which has not been able to processed, what we can be done with them, it's a dead data queue. It's go to dead data queue. Similarly, if you go to AWS Lambda here, right, if we had okay, I removed that. In the AWS Lambda, the destination part, the destination of AWS Lambda can be a dead data queue, that all the messages that has been read, if they have been processed successfully, then great. If they are not been processed successfully, then we can push them to a dead letter queue. Then we have visibility timeout, that for how much time the data would be kind of a visible or not visible. Let's say if you have standard queue, a queue has there are multiple consumers, right? So one of the consumer has read the message, then obviously the other consumer will not be able to read the message, or should not be reading the message. Otherwise, it will be multiple processing of the same message. All right. But the original consumer which has read the message has tried processing it for some time and has not been able to process. Then in that scenario, your second consumer should be able to read that message. It should be available for the second consumer to be message, unless the first confirms that I have been able to process, and we should be deleting it from the queue. If the first confirms that, great. If the first does not confirms that, then it means that it has not been processed and it should be still processed. So it becomes available again in the queue for any consumer to kind of start consuming it. And that's what the visibility timeout is, that you will be able to set your visibility timeout so that in case it needs to be reprocessed. The default is 30 seconds. The minimum is 0 seconds, that once it has been consumed, it has been consumed, and now it is the it is the responsibility of the consumer who has consumed it to process it correctly. Otherwise, the maximum can be 12 hours. So that's what the visibility timeout is. Then we have something called delay queues, that when a data comes into the queue, then how much time it should be before the consumers are able to see it. There are scenarios in which this is required. It is similar to visibility timeouts, because both features make it unavailable to consumers for a specified time of period. The difference here of the two is that delay queues are messages hidden even for the first that is added to the queue. When it's added to the queue, it is not even visible for the first consumer for some time, depending upon what the configuration is. But when visibility timeout comes into picture, it's like one of the consumer has consumed it and it is not available for the other consumers because the first consumer is still processing it. So that's the difference. So we can create a SQS. So let's do that. Let's go and create a queue. It's as simple as I'll name it as a test queue. Come on, test queue. Configuration, as I said, we can have a visibility timeout, we can have delay timeout. There are multiple things that we can do. A max message retention period, how maximum, like in case if there is no consumer, even then till what time you would like to ensure that the queue has the data. Okay, and that's minimum is 1 minute and maximum 14 days. Even if there is no consumer, the data will be still sitting in the queue for 14 days, but after that it will be deleted. What is the maximum message size? It's the maximum message size 256 KB. More than that, not the right thing. Then there are ways to save the actual message into a S3 and save here just the pointer to that or something like that. Okay, and then we have then we have basic and advanced policy. How the access policy should be. I'll keep it basic for now, and only the queue owner will be able to access you know kind of send messages and receive the messages. Data queue optional, as I said, in case if there is some undeliverable message, where should we be sending it? And then there are tags optional. I'm going to create this queue. Okay, and then so how it can be now done is that now there is a queue that is created. We can send and receive messages directly from here, or obviously we can do it through programmatically. This is the URL, and you can use your programs to send message to it or message to it. There are a lot of options here through which you will be able to do multiple stuff. SNS subscription, that to allow your queue to receive messages, subscribe it to a SNS queue. So generally in a fan out scenario, what happens is that, let's just say something happening and there are multiple consumers, then you publish it to SNS, which is simple notification service, and that notification service will get the it's a topic, so the message will be received in that topic, and there can be multiple subscribers. One other subscriber can be SQS, so you will be able to subscribe it from the SQS. Other subscribers can be, let's say you want to send an email, so SNS will be sending it to the SQS. It will also be sending an email out. It will also be sending an SMS out. It can also be giving it to some other application. So that's what SNS would be. We'll very briefly look into its console and create a topic. But then we can have Lambda triggers. So it can be triggered from a Lambda. So we can do that. Let's, in fact, we can create that, or let me, okay, I'll not do it from here. I'll probably go to the Lambda console and do it, so that it more clear for you. But you can also attach a Lambda. I think it seems like I have a Lambda here which can be attached directly. Test SQS. Then the data queue, as I mentioned, monitoring is it again. It will take you to the Cloudwatch metrics, where you'll be able to see what data has come, what data has come out, and stuff. Then tagging. Then we have access policy, that who all will be able to access this. As I said, it was only the owner, that I am the one who will be able to access it. For now, all the actions and the further resources are test queue. And who is the principal? Like I am the principal here. Okay, that's pretty much. And we can encrypt this, so all the data that is coming into this queue can be encrypted. We'll talk about KMS, which is key management service, which can be used to encrypt. So let's click on it and see what happens. If I click on edit here, if I go to encryption, I can enable the encryption here, and then I can choose the key that which so this is like customer managed key. So you can choose a customer managed key, that who is going to the key through which we will be able to encrypt the data. Okay, I'll go back to the test queue. I'm going to send and receive messages. So I have this nice UI just to test it, or you can use it. So I would say, let's say first message, and I send the data. So if you see in the read, there is a messages available. There is one message available, and it's pulling every 30 seconds. So if I go to test queue, or in fact I go to queues, if I refresh it, I'll be able to see. So if you use test queue that we have created, it has one messages available. Messages in flight is met while it is being read. Okay. So if I go back here, I go to send receive messages. If I start receive message, so I can kind of poll for messages. I can click on poll for message. It is going to poll for the message. It says that one message per second. So I got this message here. I can click on this message, and I can see what the body was. It's the first message that I sent a message. I got a message. It's as simple as that. Okay, so I'm going to now go back to my Lambda, and I'm going to create a Lambda function, which is going to get triggered whenever there is a new data that is coming into SQS. So let's say there is a producer which is producing a large amount of data, which needs to be processed asynchronously or in a serverless fashion. It is going to send data to the SQS, and your Lambda is going to get triggered on each message that is being sent to SQS. And that Lambda is going to process that data. Let's say the Lambda needs to save the data in a DynamoDB. Let's say that Lambda needs to just log it somewhere. So we'll do that. So in the blueprint, let's see if we should be having a blueprint for SQS. Yeah, SQS poller and Amazon SQS trigger that logs message in a queue. Okay. So whatever message is coming is going to queue. I'm going to configure it. Function name I'm going to do as demo SQS Lambda. So if you see here, it's created from an AWS policy template, and the policy is Amazon SQS poller permission. So this particular policy that is there, it is going to give this particular Lambda function policy, to poll it. We can always use an existing role, or we can create our own roles, but we have this sample role, so we'll use that. SQS queues. So I have a test queue through which we would want this, which we created right now. So we'll use that test queue. Batch size at number of batches that we can get in one queue, which is maximum 10, which is fine. And then enable trigger. So this is where I can do enable trigger, and that means we'll go into the Lambda console to see that how this trigger is being enabled. So whenever there is a data that is coming into SQS, it's going to, this particular Lambda function is going to get triggered. It is going to read the message, and then it is going to process that. What processing is being done? It's going, I'm not sure. It is going to simply log that. So whatever data is coming in the message. So handler, if you remember index.handler, that's what the method name is going to get the event. It's going to go through the records, and it's going to print those records. So batch size was 10. So it can, in one go, it can process up to 10 records. I'm going to create the function. Okay, and to give a role name. So I'm going to give test demo role. So this is the role that can be created. Create function. I just saw there's a question on the chat which says that I'm a bit confused here. Queue's default behavior is FIFO. Yes, okay. Yes, that's true. So a default queue is FIFO. But think about a distributor, and that's where we'll have to understand that, in a default queue, there's one data coming in, and if let's say if that particular data gets corrupted, then will you be able to retrieve it? No, right? But let's say if you create a queue which is distributed in fashion, there are multiple copies of this particular data. And then there are hundreds of data that are coming, and there are multiple copies of each of these data. Right? And in case of standard behavior, what happens is that the concept of visibility timeout comes into picture. You have multiple consumers. They've consumed one of this data. And in case if you want a full FIFO, then you need to ensure that all the copies that have been there for this particular data, which has been consumed, they have been marked as consumed. And that's the replication lag to mark all those, because it is distributed in nature now. And if you want that particular functionality, that in case if you have that strict requirement of FIFO, then you have to experience that extra lag. And that's why we have this standard configuration of FIFO. While creating the function, I did not show you, right? Sorry, that's my mistake. I'll go back to test queues. I'll create another function. And then if you see here, standard and FIFO, there are two options to create. So standard is at least once delivery. Message ordering isn't preserved. And that's mainly because we have reimagined the whole view the queue is created by making it in a distributed manner, so that it is highly available, and it is performant. But if you have a hard requirement of FIFO, then that is possible. It's just that it will be not as performant or not as highly available as standard. It will be highly available, but it will be, it'll take more time. And the details of these, if you go to the info, they'll be able to explain. And then there are, the user guide, in which I think, yes, here it is. So here, if you go to this particular link, what is Amazon SQS, or there was somewhere where it actually explains it in more detail of how exactly the full, the basic architecture. So how Amazon SQS works, the basic architecture. So this basic architecture will explain you how the full distributed queues works. So this is very interesting. It goes into a depth to explain why it has been designed in the way it has been designed. And that's where it stems the difference between the standard and the FIFO. Cool. Coming back to the demo SQS Lambda. No, not here. Sorry, SQS. Okay, demo SQS. Okay. I'm not sure why the Lambda demo SQS Lambda successfully created, but an error occurred when creating the trigger. Invalid permission ID. Okay. So it seems like it was not able to create the trigger. So let me try and create the trigger manually here. So I can always create the trigger manually here. I'll go to SQS. I should be having the test queue. And let's see if it is able to create it. Yeah, it was created. I'm not sure why it was not happened the first case. So with this SQS, and it will be able to read this Lambda. So what I'll do is that, in fact, let me click here. It is creating right now. So I have a test queue. If I refresh this, I should not be having any messages. If I go here and if I refresh it, so this test queue is enabled. So as soon as now, I'm sure you guys are able to follow this, right? Hopefully, if there's any question, please do let me know. Like I know I'm covering a lot of different topics here. So in this particular Lambda function, what has happened here is that I've created a Lambda function which reads it from a queue. I've created a queue and I've attached this queue as a trigger for this Lambda function. So this Lambda function is going to get triggered whenever there is a message that is coming in this queue. And I can always enable or disable them from here. So as soon as there will be a message in this particular queue, if I go to send receive message, and let's say I put as a message as second message, if I send the message here, your message has been sent and is ready to be received. So this message has been sent, but if I go back here and I refresh it, initially, if you remember, there was a message available, right? This is not available because instantly the Lambda got triggered. And the Lambda got triggered and it processed it. And how we will be able to know whether it processes is, let's say, because Lambda was going and putting things in logs. So we'll go to the monitoring and we'll look for that data in the logs. So in the Cloudwatch metrics, it's going to give you a lot of data, like how many times it was invoked and stuff. And as you remember, there was a detailed and basic monitoring. As of now, basic monitoring is enabled, so it is going to kind of take 5 minutes to refresh it. But we'll go to Cloudwatch logs and we'll see the logs. So for any data, application level data, you need to go to the logs. If there is some kind of audit that what is a API doing or how API is of like a function of which API got called when or something like that, it is CloudTrail. So it's very important to understand the difference between CloudWatch and CloudTrail. So Cloudwatch, through Cloudwatch, if you can also look into the application level data, even the application, like the performance of your resources, how much memory is being consumed, how much RAM is being consumed, the disk space, and the application level logs. All that is possible through Cloudwatch. But any resource level changes that has happened, that let's say your instance size has been changed, or your SQS data has been moved, or something like that. Any API level conditions, any audit specific thing, it is CloudTrail. So if you see in the log groups, we have a log group AWS Lambda, Demo SQS Lambda. This is the Lambda that we created. And for this Lambda, we do have the log files here. So if you click here, log file, if you try and see uh, uh, the data that we have created, so this would be the one, because this is the latest one. So this is the end request. Before the end request, this is, see, if you see here, this one, SQS message ID, second message. This is what we have put here. Right? It was able to process the second message here, and it showed here. So that's how it works overall. The SQS gets invoked when you put the data here in the SQS. The Lambda gets automatically invoked, and similarly Lambda can be invoked by pretty much, there are a lot of options through which they can be a trigger. So if I go back to configuration, if I add a trigger, with these many services, the Lambda is integrated, which is like almost everything. And this can be like third party also. If you see here, a Lambda can be invoked, and then the Lambda would be able to do your specific function in a serverless fashion. Any question on AWS Lambda? If not, then I'll go to SNS very quickly. I know today we have not taken a break in between. Somehow, I went with the flow and did not give a break at all. Are you guys okay to continue for like another max half an hour, or do you want a 5 minutes break in between? Yeah, if you need a break, please type it on the window and we can have a quick 5 minutes break. If not, then we'll continue. Okay, we'll continue then. So SNS is as I said, it's more of a fan out scenario. Okay, so everyone is like, let's go ahead. So we'll go ahead. So SNS, we're not going to do much of a lab here, but yeah, we'll just understand what SNS is. It's more of a simple notification service. Again, it's fully managed, so you will have all the benefits of a managed service, like highly available and performance, scalability. It's again used for decoupling publishers from subscribers, and it can have multiple subscribers. So in SQS, there can be one consumer who's consuming it, but in SNS there can be multiple subscribers. So you can SQS can subscribe from it, AWS Lambda can subscribe from it, then the REST API, or you can send it to an email. Like here, as it is shown here, you can push notifications, you can send a text message, you can put an email. There can be multiple subscribers. And that's pretty much to even create this. I think it's very simple. Go to the topics, create a topic. Like I have a few topics here. You can simply create a topic here, and it asks you for a few things, and that's pretty much. So it's a kind of understanding the scenario that when SQS is used versus when SNS is used. If it's a fan out scenario that there are multiple subscribers, it is SNS. In case there is no multiple subscribers, they are like a consumer who is consuming the messages to process it, then it is SQS. Okay. Then another subject in the serverless function would be API gateway. So this is mainly for exposing your backend service as APIs. So it gives you a fully managed API gateway service, which allows you. Give me just one moment. Let's see. Or what we'll do is we'll go through the API gateway documentation. It's a fully managed service that makes it easy for developers to like create, publish, maintain, monitor secure APIs at any scale. Yeah, they're like the front door for the application access data, and behind the scenes, you can obviously like hook. There are multiple like services through which you can integrate your API gateway, and we'll see that in a moment. But yeah, a few of the common cases are like you are integrating it with a Lambda functions to get, let's say, a serverless function, or you can have a let's say application load balancer or something like that. So if I go to API gateway, and if I, like, as you see, I work a lot with APIs. Create API. There are 4 types of APIs it supports: HTTP API, WebSocket API, REST API, and a REST API. Like this is for the mainly a private API. It is accessible only within from a VPC. It just gives a template. So let's say create a REST API. I can create a build. We can also import in case if you have a Swagger definition for the APIs. Those who have worked on APIs, they will understand. There's a Swagger definition. You can directly import it from the Swagger, or you can create it from a scratch, a new REST API or WebSocket API. I'll give it REST API 1. And then endpoint is either regional, as optimized, or private. Not going into a deep detail, but yeah, as optimized would be meant these would be optimized in terms of the edge locations that we have in CDN, or otherwise it will be more of a regional service. And then that's okay. Create an API. As you know, there are multiple verbs that you might be you can have, so you can always create those methods. Like get, delete, option, post, purge, or you can create instead of a resource, you can also create a resource, like, and then you can give it a path, and with that particular path will be having your those methods. So let's say the path is test. I'll just create this resource. So I have this test, and within this test I'll be able to create a method. Let's say the method is a get, and then there's another method, let's say method, and let's say post. So I can create these level of hierarchies. So with this test, or I'll go for the get one. So if you see here, there's an integration type. I'll be able to hook a particular Lambda to either the when so hook a particular like API, that when the API is invoked, what should be happening behind the scene. It can be a Lambda function that gets invoked. It can be another HTTP. We can mock it so that it is just a mock API that we create. Let's look at AWS service. So if you click on AWS service, obviously you can first choose which region you want, irrespective of any region. It gives all the AWS services with which you can call. So when our API gateway a REST API gets called, API gateway behind the scenes can call any of these services. Obviously, there's an integration required, which there's a UI which helps you to do that, or you can do that in like more of a code format. It's like the CloudFormation or Terraform. You will be able to do that all that through the infrastructure as a code. But this is how these many services you will be able to do that. Okay, so I'll put it as a Lambda function only here for now. Let me see if I have any Lambda function. I have a Lambda function, right? So what I'll do is that I'll take any specific Lambda function. We're not going to test them, but I'm going to take any specific Lambda functions or functions. For example, demo space though. Okay, I'll go for test hello world. What I'll do is I'll need the full ARN here. So I'm going to copy this ARN, which is Amazon resource name, the qualified ARN. I'm going to use the ARN here on the test hello world. Save. So he says that we are going to give a permission to API gateway to invoke the Lambda function. Yes, we are going to give the function. It's going to it. So when I click that, it gives me see 4 options, as you see here: method request, integration request. This mainly actually calls them the Lambda. Then we have an integration response and a method response. So in the method request, there are multiple things that you will be able to do. You can say how do you want to authorize this particular API. You'll be able to like there are multiple ways you can do it. You can use like IAM, Or there is another way, here you will see API keys. You'll be able to use API keys, or then there is a Cognito. You'll be able to hook your Cognito here. And then we have request validator. You will be, in case if the request is coming, you would like to validate the body or the header of the request, you will be able to create your request validators. It will be more of like a Lambda functions which you can create and hook here, so that you'll be able to validate the body and requests here. There are a lot of options, no need to go into each one of them unless you are like really interested and you want to create a serverless APIs. Then feel free to explore that. This is really interesting, and eventually the world will be moving towards more of a serverless architectural patterns. So a good concept to understand. Then in the integration request, as we saw, there are multiple ways we can integrate it to the backend service. It also gives you the mapping templates. So in case, let's say you are integrating it to DynamoDB, you can all directly integrate your API gateway to a DynamoDB. So if I go to AWS service, instead of AWS service, I go here and I look here DynamoDB. So let's say you have an API request coming in a specific format with a specific body. You'll be able to provide the mapping template here, that how you want that body to be converted into a DynamoDB table and save the data directly into a DynamoDB. So generally what happens is that, let's say there are for the CRUD operation, right? For a create operation, you create an API, then there is an API happening, the request comes to a specific code. The code actually reads the data that is coming and formats in a way it needs to be saved into a database and saves into database. That all can be done from the API gateway directly itself, without any like a separate compute application required. Yes, we can always have a Lambda function, and Lambda function can do that. Lambda function can receive the data, it can format in a way, and then Lambda function can save into database. But if you want to do it directly, integration between API gateway to DynamoDB, even that is possible. Not that all of these things would be very important for your exam, but these are good to know features that what our capabilities does this has. That's more on API gateway. From the stages perspective, when you have these API, you can always go to stages and you deploy them. So creating the API does not change anything. It does not deploy. You will not be able to access the API. You need to create the stage, that in which particular stage you are going to create, and then create it. And that's when you will be able to access those APIs from the internet. Authorizers, as I said, you will be able to create multiple authorizers through which you will be able to kind of authorize your APIs. It can be a Lambda or Cognito. Let's have a very quick look into Cognito. So Cognito can be acting as an IDP, which is Internet Identity Provider. It lets you to add user sign-in, and access controls to your web and mobile apps quickly and easily. It scales to a million users, definitely, and it also acts as more of in case if you have existing IDP, whether it is, let's say, uh, you want to authorize your users through Facebook or Google logins, your Cognito will be able to provide you a way to do that. So you create just the applications, you have all your users on Facebook, and Cognito will be giving you a very easy integration to authorize your APIs through users through Facebook or Google or Amazon, or anyone which are SAML compliant. So SAML is an industry standard protocol, and you'll be able to do that. That's pretty much on API gateway, I would say. Let me see which what else we would be able to cover today. We do have some time. Okay, let us cover key KMS. So KMS is like key management service. Let's look into what exactly is KMS first. You should be understanding the basics of the encryption. We have like public private cryptography. We have private cryptography. There are multiple cryptographic types, but yeah, overall KMS makes it easy for you to create and manage your cryptographic keys and control their use across the wide range of AWS services. So this particular service is integrated with almost every AWS service, and it is mainly used for encrypting your data, more specifically encrypting your data at the rest. So in case if your data is being stored in, let's say, DynamoDB, and you want the data to be database to be encrypted at rest, you would use a KMS key to do that. And every service has by default a KMS keys which you can use. But obviously there are customers who are much more security sensitive, and they should be, so they can have their own customer managed keys, so they can create their own keys. And in case if they want to have their own, like we have a hardware module which is Cloud HSM. So this allows you to have hardware security module on the AWS cloud. So if customers wants to have hardware level security, then it's a cloud-based hardware security module that enables you to easily generate and use your own encryption keys on AWS cloud. So there are organizations which are very sensitive. They would be able to have their own hardware through which they'll be able to create their own keys, so that nobody else will be able to ever access those keys. So that's thing. So anywhere if there's a question about customers who are very highly sensitive about the security and they want to use their own hardware security, then Cloud HSM is the right answer. If they want to use AWS native key management service, then it is KMS. So we'll go into KMS console, and I can create a key always. You can go for a symmetric key or asymmetric key. It's basis of cryptography. I do understand what these means. But if I go to advanced option, then it gives me that whether I want to do it through a KMS, or I want to export it from a external that I can have it, or I can have a custom key store which is Cloud HSM. So I get these options. Okay, so if you go to KMS, there are three kind of keys here. If you see in the left hand side, AWS Manage Keys. So by default, AWS has these keys. So like for say RDS, for Lex, for Lambda. In case if I go for DynamoDB and create one, it comes for different services that if I'm using any default services, the keys for them, they already have these inbuilt. But I can always create my own customer managed keys. I can create my own keys. And when I create my own keys, I do get an option to kind of rotate them. That is when I will be able to expand them, and I will be report them. So I go click next. Alias is fine. I'm not going to do that. I didn't give it. Okay. Okay. Next, it gives me a administrative key that what all permissions does this have. This key will be accessible from where all, and which all modules will be able to use these keys, and then I do those and create these. And custom key stores, as I said, it's more of a way where you can store your KMS customer keys instead of a standard KMS keys. And for the hardware modules, we need to go to Cloud HSM. So this will be like a kind of a trigger that we discussed about systems manager parameter store, right? Where we want to your application might be having data which needs to be secured. For example, database connection string itself, as simple as that. So for that, as I said, there are two options to save. First, we look into SSM, which is Systems Manager. The Systems Manager is a large module which will be tested very heavily if you are planning for SysOps or DevOps Pro, SysOps Associate or DevOps Pro. So this helps you to manage your entire AWS systems. Like let's say you are having thousands of EC2 instances, you will be able to manage all of them, the patching of them, the maintenance schedule, the full, how much they are compliant. There are a lot of things that you'll be able to do through Systems Manager. And if you see here instances and notes, there are a lot of things that we can be doing from here that Systems Manager has. I believe there can be one full certification just on Systems Manager. It is that huge, which has gone built over the time. But yeah, going to parameter store, which we discussing about. So this is where you will be able to save your parameters. They are stored in a more of a hierarchical manner that you can see. Like I have, these are the applications that I use. So I created a kind of a parameters with a specific path. I can go and create a new parameter. So let's say the name is demo/test. So this is the with path I'm creating a new parameter. I can have either standard or advanced. We'll go with standard for now. So if you see, there are 3 types of parameters that I can save in parameter store, and this is important actually: string, string list, and secure string. String is more like, just save a specific data. String list is you can save data with a like a comma, like a comma b comma c. So it's more of a a comma b comma c or something like that. Secure string is where you will be able to have a specific a key as text, but then you would be needing to provide a key with which the data is encrypted, and that's how this overall parameter is made secure. You can use the the default key that is present, which is AWS SSM keys, or you can create your own key. That's up to you. You can create their own key, and then those keys will be available here, and you'll be able to use those. So if you remember, in my KMS, I had 2 custom keys, right? Let me go there and show that. So it will be having a AWS Manage Keys, and AWS Manage Key, you see for SSM, there was a key. So this specific, so you can use the default AWS Systems Manager key. If you have customer manager keys, like in this, I have 2 customer manager keys, which I created sometime because of I was using code pipeline. So you can use either the default key for that particular service, or you can use your customer managed keys, and that keys will be used to secure your data. And when this data is secured, right, now you will be able to access these parameters via API from your application. There's a lot of tight integrations, or like out of the box integrations that are available, which you will be able to use. And this is how you actually like decouple your application configuration or application parameters from your application and store it in a third-party place, so that your application will be able to retrieve it whenever they need. And that's pretty much to understand on parameters store, that it allows you to actually save strings securely. There's an advanced option which gives you a few more options, like if I go to string, here, if you see here, parameters policies, there's an expiration policy that you can tell that this parameter is valid till this particular time or this particular relative time. There's expiration policy that you'll be able to provide a kinds of TTL, what you call it, time to live. That is what you'll be able to provide. Then we have another point, secrets manager. Secrets manager. This is also to actually store your secrets, but this goes one step ahead and says that you will be able to easily rotate, manage, and retrieve secrets throughout your life cycle. Why a rotation is required? In case if you have a database which has let's say a specific username password, you would, and there are multiple applications which are using those username password to access that particular database, you would like that your company might be having a policy of rotating those keys. Refresh cycle might be, let's say, 90 days. So like let's say every 90 day you go and change the database password. Then all the applications which are connected to the database, they also need to refresh it, right? And otherwise it will be a downtime. So you can automate this whole process using secrets manager. So what happens is that it's kind of a like a architecture which you can create where your database is using the credentials which are stored in secrets manager, and your application is also getting the secrets or the credentials from your secrets manager. And whenever there is a trigger that is happening, that there needs to be a refresh, secrets manager takes care of doing that refresh on both the sites. It's kind of a serverless fashion. And then if you want to do it on your own, it is possible. You can do it through a Lambda function. There are a lot of sample code that is available on the GitHub through which you can do it for your own applications. If I create a new secret here, So you see here, credentials for RDS database. This helps you to do it for RDS database rotation or document DB or Redshift cluster or any other database. But if you want to do it for your own, even that is possible. You can create your secret in the and do it. And then again, you can provide your encryption keys. So if you see, one is the default encryption key and other are the custom encryption keys that I have. I think that's pretty much. Yeah, I think I probably covered a lot of random topics today. We do have 9-10 minutes. We can cover a few other topics. Okay, there is a question. Briefly cover step functions also. Cool, great. We can do that. Step functions is mainly for orchestrating distributed applications. Initially, they used to have simple workflow service or something like that, I believe. SWS workflow. Yeah, I'm not sure. I'm not able to see. We used to have SWF, simply workflow service. So this was an old way to do it when there were a lot of if there are actions which need quite of workflow, which might be even involving a manual functions. That was simple workflow, but the newest version is step functions, and we'll look into that very briefly. It helps you create state machines. It's like from one a state to other state, and it helps you do it visually. So if I go to step functions, it helps you do it visually. So, and this visualization can be also be done through it's behind the scene. It is nothing more than a JSON file, so you can always edit the JSON file directly, but it also gives you a visualization of how exactly it is happening. And at each step, you have an option to either invoke a let's say a Lambda function, or invoke some other let's say a container service, ECS or EKS, and based on the outcome, whether it is passed or failed or how it is working, you will be able to define your workflow. So define steps of workflow in JSON based Amazon state language. We have our own state language. No need to go into understanding the specifics of those state languages uh, for any of the certifications. But if you are working in more serverless application, then go ahead and do it. I'll give you an example here. If I think I should be having, there is a recent blog that I wrote along with one of my partner, which is this. So like one of our partner, Chloya, Gutta Fade is one of our customer. They had this monolithic .NET application, and they modernized this using step functions and Lambda. So you can go through this blog. It explains that why the architectural decisions was taken, that why a specific database was chosen serverless, or why we used a state functions or some each of the functions, and building the solution. So if you see here, this is they had this huge ETL layer, and the partner used Amazon state function or step functions to create those different steps, and used Lambda and Fargate to implement the full service. So anyone who is interested in this enterprise level architectures, step function is a really cool service to go for, where you'll be able to design these workflows. So if you see this workflow, what happens is that whenever there's a file coming, they either download it. If there's a multi-part file, they merge it, and then when the full file is ready, they do the schema validation. Then they check for the import, and within the import they have multiple steps how they do it, and then the workflow is complete for the import part. Similarly, on the checkout, they have this full workflow. So these workflows are defined quite easily in step functions. Again, not required for your certifications. That is going way too deep into architecture if you're working day in and day out on these technologies. From a very high level perspective, do understand that why the state function is required, which all service it can be integrated with, what are its benefits. Go through a bit of the use cases in the user guide, and that should be a good enough. Any other service or any that you would like me to cover, briefly, or any other questions that you might be having? Okay, thank you guys. I'm ending the meeting now.